Today we're going to learn how to count, and we're going to start with some very simple tasks and then see how things get more complicated when we start to do more than one task in a row, or we have two separate tasks that we're doing simultaneously. So first, a very easy question. How many ways can you roll an even number on a six-sided die? So let's just specify this, that this is for sure six-sided. Well, which even numbers do you see on a six-sided die? You see the numbers 2, 4, and 6. Okay, so there's three different ways that we can roll an even number on a six-sided die. Okay, easy question. How many ways can you draw a face card in a standard 52 card deck? Well, what is a face card? A face card is any of the Jack, Queen, or King. And of course, for each of these Jack, Queen, and King, we have four different suits. We have hearts, we have diamonds, we have clubs, and we have spades, all of which I am not good at drawing. So in total, we have 12 different ways that we can draw a face card from a standard 52 card deck. There's 4 jacks, 4 queens, and 4 kings. Okay, so this is just doing one task inside of some specific domain. We have this thing called the addition rule, and this is when we have two different tasks, A and B. So we could say that A is rolling an even number and B is picking a face card. Okay, so let's say that task A can be done in M ways, and task B can be done in N ways. Then task A and B can both be done in M plus N ways. And these are when the tasks are separate. So, if we go back to that original example, we could say how many ways can you roll an even number on a die or draw a face card? In which case, we have our task A, which is rolling an even number. So there are 3 ways to do that. Then we have our task B, which is to pick a face card from the deck. And there are 12 ways of doing that. So when we say how many ways can you roll an even number, 3, or a face card from a set of 52 cards would be 12, we add them together and we end up with a grand total of 15 different ways to do either task. Either we get one of the even numbers or we get a face card from a deck. Okay, now the rule of product is slightly different. We say here with the rule of product, in subsequent tasks A and B, if there are M ways to do task A and N ways to do task B, then there are M times N ways to do A then B. In other words, these are tasks that are done one after another. With the rule of addition, it's doing one task or another one. With the rule of product, it's doing them subsequently. So here's an example of a rule of product question. Suppose I want to make a sandwich and I have 4 different steps where I have to make choices. So I need 1 piece of top bread, which can be white, whole wheat, or sourdough. I need 1 meat, so we have ham, bologna, pork, steak, salami, rabbit, and human meat. We want some vegetable, so this could be lettuce, tomato, cucumbers, or turnip. And we also have a bottom bread, which can be white, whole wheat, or sourdough. We go wild here. The top and bottom bread can be different. So how many ways can we do that? Well, it's really like having 4 different tasks that are all done one after another. For instance, first we choose a top bread, then we choose a meat, then we choose a vegetable, then we choose a bottom bread. So it's A, B, C, or D. So 4 tasks. Well, for the top bread, we have 3 different choices. Okay? For the meat, we have 1, 2, 3, 4, 5, 6, 7 choices. So ham, bologna, pork, steak, salami, rabbit, and human. For vegetables, we have 4 choices. And for the bottom bread, once again, we have 3 choices. Now, when we're doing subsequent tasks, we need to multiply. So there's 3 ways to do task A, 7 ways to do task B, 4 ways to do task C, and 3 ways to do task D. In other words, in total, there's going to be 21 times 12 different ways, which should be something like 210 plus 42, which is 252 ways in total. So there's 252 different sandwiches we can make. Okay, so to go over that logic again, essentially we're picking one from each. So we might pick white bread on top, bologna as the meat, lettuce as the vegetable, and then whole wheat as the bottom bread. Okay, so in the first task, we pick one way to do it. The second task, we pick a second way. The third task, we pick a third way, and we get 252 total options. So that's an example of the rule of product. Now, let's put this into an application. Let's say making license plates. So where I'm from, license plates consist of 6 symbols, 3 of them are numbers, and 3 of them are letters. So let's say we have some restrictions on the types of things we can put on our license plates. So for example, we want our numbers to just be 3 even numbers, and then we want 3 letters. Okay, and we're not going to be too specific about where these letters and numbers show up. They just have to show up somewhere. So 3 even numbers. Well, the even numbers between 0 and 9 are 0, 2, 4, 6, and 8. So for each of the even number spots, we have 5 different choices. So we have 5 ways to pick the first number, 5 ways for the second, and 5 ways for the third. Now for the letters, well, there's 26 different letters in the alphabet. We can have 26 letters for our first choice, 26 letters in the second choice, and 26 letters for the third choice. So in the end, we have 5 to the 3 times 26 to the 3 different license plates that we can make. Okay, so that's a lot of license plates. Now, what if we restrict ourselves in a different way? So let's do an 8 symbol license plate. So first I have to have 2 numbers. So while there's 10 numbers to choose from, 0 through 9, so we have 10 choices for our first number, 10 choices for our second number. We have 2 letters, so we need 2 cases of 26 choices here. 1 odd number, so we have 1, 3, 5, 7, and 9. That's 5 choices. 1 even number, 0, 2, 4, 6, 8. 5 choices. And then 2 vowels. So we have A, E, I, O, U. So we have 5 choices for each vowel. So what we end up with is 10 squared times 26 squared times 5 to the 4 different ways of making this license plate. Okay, so 2 numbers was our 10 by 10. 2 letters is our 26 by 26. 1 odd number is our multiplying by 5 cases. We have 1 even number as 5 cases each as well, and then our 2 vowels are each 5 cases. So we can see how these numbers line up. Okay, now here's a more interesting question. How many license plates can we make that consist of 6 letters where they're not the same letters? Okay, so this means, let's simplify this first. If we have, say, 4 letters we're choosing from, and we're going to make a 2-letter license plate out of these 4 where we can't reuse the same one, let's say for our first spot, we could pick A, B, C, or D. That could be our first spot. Well, if we pick A, then we can no longer pick A for our second slot. So really, for our first slot, we have 4 choices that we can choose from. With our second slot, because we can't pick A, we only have 3 choices left. So if we're working with just 4 letters, and we want 2 spots, our solution is going to be 4 times 3. So if we have 6 letters that are not the same, then for our first slot, we have 26 choices. And whatever letter we pick, we can't reuse. So for our next slot, we have 25 choices for the second slot, 24 for the third slot, 23 for the fourth slot, 22 choices for the fifth slot, and 21 choices for the final slot. So this is how many license plates we can make where the letters are not the same. So this is it for the rule of addition and for the rule of product, also known as the product rule and the addition rule. If you have any questions, leave them in the comments below, and I will get back to you as soon as I can.